we are presenting SUP-NeRF, a streamlined unification of pose estimation and NeRF for monocular 3D reconstruction. Since 2020, a large family of neural reconstruction methods have been developed. NeRF techniques have clearly revolutionized the 3D reconstruction field. Meanwhile, object-centric NeRF represents a valuable variant within the NeRF family. Specifically, it enables a new approach to monocular object reconstruction by integrating prior knowledge with online optimization. However, this method typically relies heavily on accurate object poses. In this paper, we identified the root cause of the issue as the well-known depth scale ambiguity in monocular 3D vision. For example, when object rotation R is perfect, but translation T is inaccurate, we allow NeRF to jointly optimize RT and the object's shape and texture. However, we observe that the optimization tends to resize the object rather than adjust the translation to minimize photometric loss. Such limitation of NeRF in addressing depth scale ambiguity suggests the need of an additional pose estimation module. Nonetheless, this introduces further challenges related to method efficiency and cross-domain generalization. To solve the identified challenges, we introduced a new method that estimates an object pose, shape, and texture in a unified framework. Simultaneously, the method handles scale depth ambiguity, guarantees the high efficiency, and achieves cross-domain generalization. Here is the SUP-NeRF pipeline. The top half represents a typical object-centric NeRF pipeline, but in addition, we leverage the shared image encoder to output object dimensions and pose code to facilitate the lightweight pose estimation model. Specifically, a shared image encoder is necessary to maintain the high efficiency. Separating 3D dimension estimation and object pose estimation is the key in handling depth scale ambiguity. Our pose estimation module is designed for superior cross-domain generalization capability. We invent this unique project box representation so that the pose refining network only deals with image domain representations which are independent from camera intrinsic parameters. Such design is crucial for the improvement of cross-domain generalization where different camera specs are involved. Here we demonstrate how our method iteratively refines pose, shape, and texture in 2 stages. Initially, our approach starts with a random object pose, and with just a few iterations, the pose refiner can effectively approach the true pose. In the later stage, the object-centric NeRF can focus on the reconstruction of the shape and texture and a relatively stabilized pose. Quantitatively, we first compare our method with the prior methods on nuisance dataset and their in-domain evaluation setup. As observed, our method leads to consistent improvement upon prior methods in most of the matrices, and we show more significant advantage in geometry matrices. Similarly, we also compare our method with others on Kitty dataset, but under a cross-domain evaluation setup. Specifically, all the methods are trained on nuisance, but tested on Kitty. As observed, our method still leads to consistent improvements in most of the matrices, and we show even more significant advantage in geometry matrices. In a visual comparison with the auto-RF baseline, we observe that SUP-NeRF produces more complete shape, sharper texture, and demonstrate high accuracy in both rotation and translation. However, single-view reconstruction remains highly challenging due to occlusions, with reconstruction quality significantly lagging behind that of multi-view methods. Similarly, in the visual comparison with the booty-in baseline, the integration of our pose module results in more accurate shape and reconstruction and occlusion, along with improved accuracy in rotation and translation estimation. However, challenges posed by occlusion remain evident. Thank you for watching. Here we summarize the contributions of our paper. For more details, please check our paper and project page.